In the last few videos, we looked at our properties of logs and how we can use them to expand a logarithm. So in this video, we're going to look at going the opposite direction, and we're going to take multiple logs that are added and subtracted together in order to work backwards and condense them into a single log. So basically, if you're thinking about our three main properties, the product, quotient, and power rule, we're going to be going from the left to the right. So if you have a sum of two logs, you can condense them back together as a product. If you have a difference of two logs, you can condense them back together as a quotient. And if you have a coefficient out front, then you can pull it up as an exponent. Okay, so let's go ahead and look at some examples of condensing. We are going to condense each expression and simplify if possible. Okay, so let's look at a few examples. Let's say we have first the log of 4 plus the log of 25. So if we're thinking about our three properties, if you have two terms that are being added together, then you can condense them with the product rule and multiply. So this would become the log of 4 times 25. Well, then we can simplify that to the log of 100. And because we know that a log without a base is understood to have a base of 10, and we know that 10 to the power of 2 is equal to 100, this is just 2. All right, similarly, let's say we have the log base 4 of 2 plus the log base 4 of 32. Again, it's addition, so we can use the product rule to condense this, and it would become the log base 4 of 2 times 32. We can simplify that. So it would be the log base 4 of 64. And then if we think of simplifying this, 4 to the power of 3 is equal to 64, so that just becomes 3. All right, let's do the natural log of x minus the natural log of 7. So on this one, if we think about our properties, whenever you have subtraction, you can condense with the quotient rule. So we put this back together as a fraction. So this would become the natural log of x divided by 7. The argument of the first term goes on top. The argument of the second term goes on the bottom when you're subtracting. Let's do the log of x squared minus 16 minus the log of x minus, oops, I have two different kinds of logs here. The log of x minus 4. All right, so again, we have subtraction, so we can put this back together with our quotient rule. So we would get the log of x squared minus 16 divided by the quantity x minus 4. Well, I noticed that that numerator is a difference of squares, so I'm actually going to go ahead and factor that as x minus 4, x plus 4. And then the x minus 4s are going to cancel out, and we're left with the log of x plus 4. All right, so subtraction, you're thinking quotient rule, make it a fraction. Okay, let's do a couple more of these simple ones. What am I on? E. Let's do 4 times the log of x. All right, so whenever you have a coefficient in front of a log, those you're thinking power rule. So whenever you have a number out front, you can pull it up as an exponent using your power rule. So here, the 4 I'm just going to pull it up as an exponent. So this would become the log of x to the power of 4. All right. Similarly, say I had 1/2 times the natural log of y. Again, the coefficient can be pulled up as a power. So this would be natural log of y to the power of 1/2. And then this we could simplify a little bit because remember that rational exponents are really just radicals. So this is the same as the natural log of the square root of y. All right, let's look at some examples where we have multiple properties in one example. So let's look at our order of operations. All right, so we've looked at what to do when we have multiple properties when we're expanding. And we said in expanding, you do quotient, product, and power. So when we're condensing, because we're going the opposite direction, we have the opposite order of operations. So first, we do our power rule. Then we do our product rule. And last, we do our quotient rule. So when you're condensing, you do power, product, quotient. It's the opposite of when we were expanding. All right, so let's condense and simplify. Okay. All right, let's say we have the natural log of 3 plus the natural log of x minus the natural log of 5. Okay, so again, when we're condensing, we're thinking power, product, quotient. All right, well, on this one, if we're thinking about our power rule, none of these logs have coefficients on them, so there's nothing to do with the power rule. I'm not sure if I said product. There's nothing to do with the power rule. So next, look for the product rule. So look for terms that are being added together. Okay, and that would be these first two. You have the natural log of 3 plus the natural log of x. So those can be combined with our product rule to become the natural log of 3x. And then lastly, because these two are being subtracted, we can combine them with our quotient rule, and we would get the natural log of 3x divided by 5. All right, let's do another. Say we have 3 times the log of x minus the log of the quantity x plus 2. All right, again, power, product, and then quotient. So this time I can see that our first log has a coefficient of 3. I'm going to start by pulling that up with our power rule. That's going to become the log of x cubed minus the log of x plus 2. We have no terms on this one that are being added, so there is no product rule, but we do have these two terms that are being subtracted, so we'll have our quotient rule, and that'll become the log of x squared divided by, or x cubed, sorry, x cubed divided by x plus 2. That's going to be our final answer. All right, let's do another one. Let's say we have 1/3 times the log of x plus 2 times the log of 7 minus the log of y. All right, so start with our power rule. So that would be the 1/3 can come up as an exponent, and the 2 can come up as an exponent. So that would become the log of x to the power of 1/3 plus the log of 7 squared minus the log of y. All right, now both of these first two terms we can simplify a little bit. So our 1/3 exponent, remember that's the same as a cube root. And then the 7 squared, we can just change to a 49. All right, so after power rule, we look for product rule. So for this, we're looking for terms that are being added together. So that would become the log of 49 times the cube root of x. And then lastly, quotient rule. We have these two terms that are being subtracted. So we would end up with the log of 49 times the cube root of x all over y. All right, let's do 6 times the natural log of x minus 2 times the natural log of y minus the natural log of 3. All right, so again, start with our power rule. So the 6 can come up and the 2 can come up. So we have natural log of x to the power of 6 minus the natural log of y squared minus the natural log of 3. All right, now something that's a little bit different about this one is we have two terms that are being subtracted, okay? General rule of thumb, whenever you have multiple negative terms, what you're going to want to do with it is factor out the negative. So I'm going to rewrite this, and I'm going to factor that negative out. So this would become natural log of y squared plus the natural log of 3. So again, anytime you have multiple negative logs, so multiple terms that are being subtracted and you're trying to condense, factor the negative out, okay? Now the reason why I'm doing that is because now I can see that these last two terms are being added really, so we can use our product rule on them. So this would become the natural log of x to the 6th minus the natural log of 3y squared. And then lastly, because these are being subtracted, we can use our quotient rule, and we would get the natural log of x to the 6th divided by 3y squared. All right, let's go ahead and do one more example. Let's do 1/2 log of x minus the log of y plus 2 times the log of 3 minus the log of 12. Okay, so this one is a little bit more complicated than any of the others we've looked at. You'll notice again that we have multiple terms that are being subtracted, but they're not side by side. So the first thing that I like to do when I have my terms kind of all jumbled up like this with this one's a positive, a negative, a positive, a negative, I like to rearrange it. So my positive terms are at the front and my negative terms are at the back. So I'm going to go ahead and rearrange this as 1/2 log of x plus 2 log of 3 minus log of y minus log of 12. Okay, so rearrange that so that your positive terms are up front and your negative terms are at the back. Okay, now we can start expanding, thinking power, product, quotient. So power, we're going to pull any coefficients up as exponents. So we would get log of x to the 1/2 plus log of 3 squared. Last two terms stay the same. We can simplify the log of x to the 1/2 as the log of the square root of x, and we can simplify our 3 squared to a 9. All right, well then just like the last one, these last two terms are both being subtracted. So again, what I'm going to do with it is I'm going to factor out that negative. So factor the negative out of both of those terms. And that becomes then log of y plus the log of 12. Okay, well, once we do that, we can see these first two terms are being added, so those can be condensed with the product rule, and the last two terms are being added, so those can also be condensed with the product rule. So this would become the log of 9 times the square root of x minus the log of 12y. All right, and then our last step here, we have subtraction. So these are going to be condensed with the quotient rule. So we would get the log of 9 times the square root of x divided by 12y. Okay. And the last thing we can do, since we have a 9 over 12, we could just reduce that fraction. So both of those terms are divisible by 3, so we could reduce it to 3 over 4. So we would get the log of 3 times the square root of x divided by 4y. All right, guys, so that is it for our log properties. So definitely do the homework, do the lab, and email me if you have any questions.